March 23, 1945, near Oppenheim on the Rhine River. The scene that unfolded before Wehrmacht artillery spotters defied everything German military doctrine said was possible. Through the morning mist rising from the Rhine's turbulent waters, American vehicles were crossing on what appeared to be a bridge that hadn't existed 12 hours earlier. Not a hastily assembled emergency crossing of planks and boats, but a fully operational bridge capable of supporting 40-ton Sherman tanks. German observers reported the impossible to their commanders. The Americans had constructed a complete treadway bridge across one of Europe's mightiest rivers in darkness, under sporadic artillery fire, in approximately 11 hours. The Wehrmacht's own engineer units, despite being the inheritors of centuries of German military engineering tradition, required a minimum of 48 to 72 hours to construct a comparable crossing under ideal conditions. Most German bridging operations in 1945 took 5 days or more, if they could be completed at all, given the chronic shortage of materials and specialized equipment. Yet here were American engineers, working through the night of March 22nd, completing what German doctrine classified as a multi-day operation before the sun had reached its zenith. At German 7th Army headquarters, staff officers struggled to comprehend the reports flooding in from the Rhine's eastern bank. American forces were pouring across at multiple points simultaneously, each crossing supported by different types of bridges that seemed to materialize from nowhere. The transformation had begun 3 years earlier, in 1942, when the United States Army revolutionized military bridging through a combination of mass production, standardized equipment, and radical doctrinal changes that would render German bridging capabilities obsolete. While Wehrmacht engineers still depended on techniques barely changed since World War I, American forces were deploying the M2 Treadway Bridge, a marvel of military engineering that could be transported on standard trucks and assembled in darkness by men who had never worked together before. Each 12-foot steel treadway section could be maneuvered by 6 men using nothing more than muscle power and simple hand tools. No cranes, no special vehicles, no lengthy preparation required. The engineering revolution was orchestrated by men whose names would never achieve the fame of Patton or Bradley, but whose innovations proved equally decisive. Colonel S.R. Kelly of the Corps of Engineers had overseen the development of the treadway concept at Fort Belvoir, Virginia, transforming theoretical designs into practical military equipment. Major William McKinney had solved the critical problem of how to connect bridge sections in swift water without endangering the engineers. Their solution was elegantly simple: prefabricated steel treadways with integrated flotation, connected by pins that could be inserted even in total darkness by feel alone. The system was so intuitive that engineers from different units, speaking different languages, could work side by side effectively. The Brockway Motor Company of Cortland, New York, had been selected to manufacture the specialized trucks that would carry this revolutionary equipment. Each Brockway model, B6666-ton truck, could transport components for exactly 30 feet of bridge, including steel treadway sections, pneumatic floats, and connecting hardware. The trucks themselves became part of the bridging system, with integrated cranes and winches that eliminated the need for separate heavy equipment. By early 1943, American factories were producing 200 Brockway bridge trucks per month, along with the specialized trailers, boats, and outboard motors that comprised the complete bridging system. December 1943, the Italian campaign provided the first major test of American bridging superiority. At the Volturno River, the 3rd Infantry Division needed to cross 400 feet of swift water under German observation. Wehrmacht intelligence estimated any bridging attempt would require at least 60 hours and be visible from miles away. The 16th Armored Engineer Battalion accomplished it in 9 hours, working entirely in darkness. The key lay not just in equipment, but in organization. Every American combat engineer battalion included organic bridging companies equipped with standardized equipment. Each company could construct 200 feet of floating bridge independently. When multiple companies worked together, they could span virtually any water obstacle in Europe. The contrast with German capabilities was catastrophic. A standard Wehrmacht infantry division in 1944 possessed one bridging column with equipment that hadn't substantially changed since 1918. The Brückengerät B, Germany's standard military bridge, required specialized vehicles for transport, could only be assembled in daylight and demanded extensively trained personnel. Most critically, the German system required 48 hours minimum to bridge a 300-foot river, and that assumed no enemy interference and perfect conditions. By January 1944, the German High Command's own reports acknowledged that American forces could establish river crossings 5 times faster than Wehrmacht engineers. The Bailey Bridge represented another dimension of American engineering superiority. While the British had invented the Bailey Bridge, American mass production transformed it from a specialized tool into standard equipment. The 15th Engineer Battalion could assemble a 180-foot Bailey Bridge in 4 hours, a task that German engineers, when they had comparable equipment at all, required 2 days to complete. The development of truck-launched Bailey bridges meant that American engineers could begin assembly on one bank and push the completed bridge across the gap without anyone setting foot on the far shore. The 291st Engineer Combat Battalion exemplified American engineering prowess. Commanded by Lieutenant Colonel David Pergrin, the 291st had trained at Camp Swift, Texas, where they practiced assembling bridges blindfolded, in rainstorms, and under simulated artillery fire. Each man could perform every task in the bridging operation. There were no specialists whose absence could halt construction. This redundancy proved critical in combat, where casualties were inevitable. March 7, 1945, the capture of the Ludendorff Bridge at Remagen stunned the German High Command, but what followed proved even more devastating. The 291st Engineer Combat Battalion, working with the 988th and 998th Engineer Treadway Bridge Companies, began constructing an M2 Treadway Bridge on March 9th at 8:30 a.m., about 400 meters downstream from the damaged railroad bridge. Despite constant German artillery fire that caused 35 casualties, including 17 killed or wounded during one barrage that destroyed 19 pontoon floats, they completed the first tactical bridge across the Rhine in 32 hours, finishing at 5:10 p.m. on March 10th. Meanwhile, the 51st Engineer Combat Battalion built a 969-foot heavy pontoon bridge upstream between Kripp and Linz in just 27 hours, the fastest floating bridge ever constructed under fire. The speed came from revolutionary preparation and logistics. The 1,139th Engineer Combat Group, supporting Patton's Third Army, maintained forward supply dumps containing complete bridge sets pre-positioned within 5 miles of anticipated crossing sites. Trucks loaded with bridging equipment followed immediately behind advancing armor. When a destroyed bridge was encountered, engineers could begin construction within an hour. The Germans, by contrast, typically required 24 to 48 hours just to bring bridging equipment to a crossing site, assuming they had any available. By 1945, most Wehrmacht units had no bridging capability whatsoever. The American system's greatest advantage lay in its simplicity and standardization. The Engineer Field Manual FM 5-10, Construction and Employment of Fixed and Floating Bridges, established procedures so standardized that engineers from different divisions could work together seamlessly. Every piece of equipment was interchangeable. Every soldier knew the standard procedures. A sergeant from the 249th Engineers could take command of a platoon from the 51st Engineers and continue bridge construction without missing a beat. This interoperability was impossible in the German system, where each unit's equipment and procedures varied. Lieutenant Hans Müller of the German 47th Volksgrenadier Division, captured near Mainz, described his amazement. "We destroyed the bridge at 1600 hours and prepared defensive positions, expecting several days to prepare. By 0400 hours, American tanks were crossing on a new bridge. We didn't understand how this was possible. In the Wehrmacht, such construction required a week of planning and specialized engineer units that no longer existed. Mueller's division had lost its organic engineer company in Normandy and never received replacements. Even when German engineers were available, they lacked basic materials. A March 1945 Wehrmacht report noted desperate shortages of lumber, steel, rope, and even nails. The American advantage extended beyond speed to versatility. The M2 Treadway Bridge could be reconfigured as a ferry in 30 minutes, allowing immediate crossing of reconnaissance elements while the bridge was completed. The heavy pontoon bridge could support 70 tons. Loads, accommodating the heaviest Allied equipment. The infantry support bridge could be assembled by combat troops, without engineer assistance. This flexibility meant American commanders could maintain offensive momentum regardless of water obstacles. General Omar Bradley's 12th Army Group had crossed more than 60 major water obstacles between Normandy and the Rhine, each crossing accomplished faster than the last as procedures were refined. The average time to bridge a 200-foot river had dropped from 18 hours in June 1944 to under 4 hours by March 1945. The 1110th Engineer Combat Group's report from March 20, 1945, recorded bridging the main river in 3 hours and 27 minutes, including approach roads. Such speed wasn't exceptional, it had become routine. The industrial miracle behind this capability was staggering. American factories produced 5,800 Brockway bridge trucks, 230,000 pneumatic floats, 14 million square feet of steel treadway, and enough Bailey Bridge components to span 50 miles of river. The Harsco Corporation's plant in Harrisburg, Pennsylvania alone produced 4,000 tons of bridge components monthly. Each component was manufactured to tolerances of 1/16 of an inch, ensuring perfect interchangeability. The training infrastructure matched the industrial effort. The Engineer Replacement Training Center at Fort Belvoir graduated 2,000 bridge specialists monthly. Camp McCain, Mississippi, featured exact replicas of European rivers where entire engineer battalions practiced assault crossings. The 540th Engineer Combat Regiment conducted 147 practice crossings before deploying to Europe. By contrast, German engineer replacements in 1945 often received less than 2 weeks of training, many never seeing actual bridging equipment before reaching the front. The night of March 22 to 23, 1945, exemplified American engineering dominance. While Montgomery's Operation Plunder prepared its elaborate Rhine crossing with weeks of planning and massive artillery preparation, Patton ordered the 5th Infantry Division to cross immediately at Oppenheim. The accompanying engineer units had 6 hours' notice. Working in total darkness, the engineers launched assault boats at 10:30 p.m. By midnight, infantry was securing the far shore. By 4 a.m., a heavy pontoon ferry was operational. By noon on March 23rd, a complete M2 Treadway Bridge spanned the Rhine. The German response revealed their complete inability to counter American engineering capabilities. Field Marshal Albert Kesselring ordered the Luftwaffe to destroy the Oppenheim Bridge. 42 sorties dropped over 60 tons of bombs. The bridge suffered minor damage, repaired in 2 hours. Even when German aircraft managed to destroy bridge sections, American engineers simply floated replacement sections into position. The 994th Engineer Treadway Bridge Company's war diary noted, "Bridge damaged by enemy action 1430 hours. Repairs complete 1615 hours. Traffic resumed. The systematic superiority extended to every aspect of bridge operations." American bridges featured integrated lighting systems powered by portable generators, allowing night traffic at full speed. German bridges, when they could be built at all, required vehicles to cross slowly in darkness. American engineers installed anti-mine booms upstream of bridges, deflecting floating explosives. American bridges included telephone lines connecting both banks, coordinating traffic flow. By late March 1945, the Rhine had ceased to be an obstacle for American forces. The 1159th Engineer Combat Group had constructed 6 bridges in 5 days, each capable of handling 1,000 vehicles daily. The entire 9th Army, over 300,000 men with their equipment, crossed in 72 hours. German staff officers, trained to think in terms of week-long river crossing operations, couldn't adjust their planning to American speed. General Günther Blumentritt, Chief of Staff of the German Western Command, later admitted, "We based our calculations on our own crossing times." The Americans crossed in 1/5 the time we considered physically possible. Captain James Morrison of the 146th Engineer Combat Battalion described the routine that had developed. "We'd get word that a bridge was blown. By the time our reconnaissance arrived, the assault boats were already launching. While infantry secured the far shore, we'd be assembling the bridge. The whole thing became automatic. My men could build a 200-foot treadway in their sleep, and sometimes nearly did. The Germans kept destroying bridges thinking it would delay us. It never worked. Morrison's company built 23 bridges in 30 days. The floating Bailey Bridge combined British design with American mass production to create unprecedented capabilities. The 148th Engineer Combat Battalion assembled a 1,258-foot floating Bailey across the Rhine at Remagen starting March 18th, completing it in less than 36 hours despite constant artillery fire. The bridge used 374 pontoons, 612 Bailey panels, and 14,000 individual components, all fitting together with precision despite being manufactured in dozens of factories across America. The human dimension proved equally decisive. American combat engineers brought practical experience from civilian construction, farming, and manufacturing. Private First Class Angelo Tortorelli of the 291st Engineers had been a construction worker in Newark. Sergeant Robert Knox of the 51st Engineers had built bridges for the Pennsylvania Railroad. These men understood machinery, concrete, and steel in ways that career German soldiers did not. When standard procedures failed, American ingenuity prevailed. The German engineering failure wasn't about courage or skill, but systemic obsolescence. The German Brückengerät B bridging column required 40 specialized vehicles, most of which Germany couldn't produce after 1943. American bridging equipment fit on standard trucks, thousands of which rolled off Detroit assembly lines monthly. German doctrine required extensive reconnaissance and planning. American doctrine emphasized speed over perfection. Colonel Franz Gerhardt, commander of German engineer troops in the Ruhr Pocket, captured in April 1945, testified, "Your bridges appeared faster than we could destroy them. We would blow a bridge, report the crossing blocked, and within hours American vehicles would be crossing. My own engineers required a week to build what yours accomplished overnight. We knew about your equipment superiority, but we didn't understand your organizational superiority. Every American unit seemed capable of building bridges. In the Wehrmacht, only specialized engineers could do this work, and by 1945, most of them were dead or captured." The statistics told the complete story. During the Rhine crossings of March 1945, American engineers constructed 62 bridges totaling over 35,000 feet in length. The average construction time was 8.7 hours. German forces during their 1940 advance into France, at the peak of Wehrmacht capability, had required an average of 73 hours to construct comparable crossings. By 1945, German forces often couldn't build bridges at all, lacking materials, equipment, and trained personnel. The revolution extended beyond bridges to the entire support system. The 331st Engineer General Service Regiment operated floating maintenance shops that could repair damaged bridge components on site. The 453rd Engineer Depot Company maintained stockpiles of replacement parts within 10 miles of every crossing site. This infrastructure meant that American bridges, once built, stayed operational. German bridges, lacking such support, often became unusable within days. The impact transformed military operations. American armored spearheads advanced, knowing destroyed bridges wouldn't stop them. German defenders couldn't rely on water obstacles for protection. Lieutenant Klaus Weber of the 3rd Panzer Grenadier Division wrote, "The Americans have made rivers meaningless. We blow bridges. They build new ones overnight. It's not warfare as we understand it. They don't fight the river. They simply ignore it." The crossing of the Danube River in April 1945 demonstrated the culmination of American engineering supremacy. The 14th Armored Division needed to cross 1,200 feet of swift water. The attached 13th 1003rd Engineer General Service Regiment accomplished it in 7 hours using standard equipment, building 2 treadway bridges simultaneously from both banks toward the middle. German forces, expecting days to prepare defences, were overrun before they could respond. The industrial foundation deserves emphasis. Bethlehem Steel produced 14,000 tons of bridge components monthly by 1945. Firestone manufactured 400,000 pneumatic floats, each tested to 5,000 pounds of pressure. Evinrude produced 15,000 specialised outboard motors. Equipment failure rates were below 0.1%. German industry, bombed and resource-starved, couldn't maintain existing equipment, much less produce new materials. A captured German report noted only 15% of authorised bridging equipment was available. Master Sergeant Harold Davies of the 234th Engineer Combat Battalion summarised, "The Germans thought rivers would slow us down because rivers slowed them down. They planned their defences assuming we'd need as much time as they did. But we'd turned bridge building into an assembly line operation. Every piece was standardized. Every man knew his job. A destroyed bridge meant a few hours' delay, nothing more." The tactical implications transformed military planning. American commanders could maintain continuous offensive pressure regardless of terrain. German military schools had taught for centuries that rivers were supreme defensive positions. American engineers rendered this doctrine obsolete. Field Marshal Gerd von Rundstedt admitted, "The Americans' ability to cross water obstacles at will was decisive. We could not establish stable defensive lines. Every river we expected to hold for weeks fell in days or hours." Training statistics revealed systematic superiority. American combat engineers received 420 hours of bridging training versus German pioneers' 40 hours in 1945. American engineers practiced night bridging weekly. German doctrine emphasized daylight construction. American units maintained 100% equipment availability. German units reported 30% or less operational. The final Rhine crossings demonstrated total American dominance. On March 24, 1945, during Operation Plunder, the 17th Armoured Engineer Battalion constructed a 1,152-foot treadway bridge at Wesel in 6 hours and 15 minutes, setting a record for the longest floating bridge built under fire. The 275th Engineer Combat Battalion built a 969-foot heavy pontoon bridge at Wallach in 14 hours. German forces could only watch as American engineers turned the Rhine into just another river to cross. By April 1945, American forces crossed every major water obstacle in Germany faster than German forces could retreat across them. The 2nd Armoured Division crossed 8 rivers in 7 days. The 83rd Infantry Division crossed the Rhine, Main, Weser, and Elbe rivers, each crossing accomplished faster than the previous one. German forces, unable to establish defensive positions before Americans arrived, simply disintegrated. General Walter Model's final operational order on April 14, 1945, stated, "Enemy bridging capabilities make river lines untenable. Withdraw from water obstacles immediately as they provide no defensive value." This admission from one of Germany's most capable commanders confirmed what American engineers had achieved. They hadn't just built bridges. They had eliminated rivers as military obstacles. The capture of German bridging equipment provided stark comparisons. The German Brockway K required 72 hours minimum for a 300-foot span. The American M2 Treadway could span the same distance in 6 hours. The technical superiority was overwhelming, but organizational superiority proved even more decisive. Colonel Herbert Mitchell, commander of the 1104th Engineer Combat Group, observed, "The Germans never understood that our speed came from standardization and training, not from some magical technology. Every bridge was built the same way. We didn't need to plan each crossing. We just executed the standard plan faster each time." The human cost differential was telling. American engineer casualties during river crossings averaged 2.3% versus German rates exceeding 15%. American speed meant less exposure to enemy fire. The 541st Engineer Shore Regiment crossed the Rhine with 1,247 men, suffering 11 casualties. The German 47th Engineer Battalion lost 340 of 600 men at the same crossing. Supply statistics for March 1945 illustrated American industrial dominance. Third Army engineers alone consumed 4,000 tons of bridging equipment, 300,000 gallons of fuel, 50 miles of rope and cable, and 2 million board feet of lumber delivered on schedule. German forces received less than 10% of requested engineering supplies. Post-war analysis was revealing. Soviet observers noted American success depended on standardized equipment, universal training, and decentralized execution. The Soviets adopted American bridging equipment wholesale. British forces adopted American deployment techniques. The defeated German army's analysis concluded that American bridging capability had been as decisive as air superiority. General Heinz Guderian, in Soviet captivity, sent a message to former Wehrmacht officers. "The Americans defeated us not through superior courage or tactics, but through superior systems. Their ability to cross rivers at will meant our entire defensive doctrine was obsolete." The legacy extended beyond World War II. The principles established by American combat engineers, rapid deployment, standardized equipment, universal training, and decentralized execution, became the foundation of modern military bridging doctrine worldwide. Field Marshal Wilhelm Keitel's interrogation after Germany's surrender included a telling exchange. When asked about American tactical superiority, he responded, "You could cross rivers as if they weren't there. We would establish a perfect defensive position behind a water obstacle, and within hours American tanks would be crossing. You had eliminated nature itself as our ally. The numbers tell the complete story. American engineers constructed over 3,000 bridges, totaling more than 1 million feet during the European campaign, averaging 11 hours construction time. German forces managed fewer than 400 bridges, averaging over 80 hours. The transformation was complete. Rivers ceased to be obstacles for American forces, while remaining insurmountable barriers for German ones. General Franz Halder, former chief of the German General Staff, writing in 1948, admitted, "The American bridge truck was more decisive than the atomic bomb. The bomb ended the war, but the bridge truck won it. Every calculation we made assumed rivers would delay Allied advances. When this assumption proved false, our entire strategy collapsed." American combat engineers achieved something remarkable. They transformed bridge building from an art into a science, from a specialist capability into a universal skill, from a time-consuming operation into a routine evolution. They turned trucks into bridges, rivers into roads, and obstacles into opportunities. Every American soldier who crossed a river dry-footed, every tank that maintained its advance, every supply truck that reached the front lines, owed their success to engineers who had made the impossible routine. In modern warfare, the ability to overcome obstacles at speed is more important than the ability to create them. The side that can maintain mobility wins. American combat engineers of World War II proved this principle definitively. They turned trucks into bridges overnight, and in doing so, turned the tide of history. German command never knew what hit them. By the time they understood the revolution occurring before their eyes, American tanks were already across the next river, and the war was effectively over. The bridge truck, not the tank or bomber, may have been World War II's most decisive weapon, hidden in plain sight, transforming warfare one river crossing at a time.